the difference between the unit cell and the primitive cell today. As we know, unit cell is nothing but the smallest region of space which can generate the entire lattice of the crystal by repetition through lattice translations. For example, if you see the square unit cell below mentioned figure, so the square is the unit cell here, and if you repeat it through the lattice translation, you can generate the entire entire lattice of the crystal. The only difference is that the unit cell is the smallest region of space, or the smallest unit, you can say. So if you see the primitive cell has only lattice points at its corners. For example, if you take the space lattice, it can be of any shape. Only thing is that it should have only lattice points only at its corners. You can choose any shape. But if you have to see the difference between the unit cell and the primitive cell, the first difference is that primitive cell has lattice points only at the corners of the cell. But the important note here is that the unit cell is not restricted to always have one lattice point per unit cell. It can have even more also. But it is the smallest unit which, when repeated in 3 dimensions, generates the entire space lattice. The same thing you can do with the primitive cell also. That this is also a geometrical shape. So if you can repeat indefinitely in 3 dimensions, it can also generate a space lattice, but only thing is that it has only lattice points at its corners. Only one effective lattice point per primitive cell. And unit cell is not restricted to have only one lattice point per unit cell. And one more important note is that unit cells are not primitive cells, except in the case of simple cubic. Simple cubic has only atoms at the corners of the unit cell. So the same with the primitive cell also, which have lattice points at the corners. So only in the case of simple cubic, the unit cell coincides with the primitive cell. But in almost in all the cases, unit cells are not primitive cells. For example, in the same cubic system, if you see the BCC unit cell, it has the 2 lattice points per unit cell. So it has atoms at the corners of the unit cell as well as at the body center. In case of FCC, we have 4 effective lattice points per unit cell, where atoms are sitting at each corner of the unit cell as well as at the all 6 space centers. Within the cubic system only, we are seeing that for simple cubic, the unit cell coincides with the primitive cell, but not with the BCC or the FCC. So unit cell is always, it can have one or more than one lattice point per unit cell. This is the important point that you should remember. Only in case of simple cubic structure, only the unit cell coincides with the primitive cell. One more example is also there. One more important note. In case of HCP, hexagonal close packed system, here for generating the HCP crystal structure, that hexagonal close packed, we use 3 hexagonal primitive cells.